Dear students, I am Tanmoy Ghosh, Mechanical Engineering Department of Sri Ramakrishna Institute of Science and Technology. Today I discuss torsion of solids and hollow circular shafts. It is the part of advanced strength of material under West Bengal State Council of Technical Education. At first, what is torsion? This is the symbolic representation. And what is the torsion? Torsion is the twisting of a rod or beam as a result of an applied torque. The amount of twisting depends on applied torque, length of the rod or beam, modulus of rigidity, and torsional constant J. That is, theta equals to tau L upon C into J. Now, what is torque or turning moment or twisting moment? In factories and workshop, shafts is used to transmit energy from one end to other end. To transmit the energy, a turning force is always applied either to the rim of pulley keyed to the shafts or to any other suitable point at some distance from the axis of the shaft. The moment of couple acting on the shaft is called torque or turning moment or twisting moment. In this figure, there is an axis of the shaft and orange curved arrow line shows the torque. Now, some important parameters related to the torsion. At first, we should know that what is shaft? A shaft is a rotating machine element, usually circular in cross section, which is used to transmit power from one part to another, or from a machine which produces power to a machine which absorbs power. Now, what is torque? Movement around the axis. Torque is a movement that twists a structure. In this figure, green arrow line shows the torque, that is in Newton meter. Unlike axial loads, which produces a uniform or average stress over the cross section of the object, a torque creates a distribution of stress over the cross section. Now, what is shear stress in shaft? It is denoted by tau when a shaft is subjected to equal and opposite end couples whose axes coincide with the axis of the shaft. The shaft is said to be in pure torsion. What is pure torsion? Pure torsion, a member is said to be in pure torsion when its cross section is subjected to only torsional moments or torque and not accompanied by axial forces and bending moment. And at any other point in the section of the shaft, stress will be induced. This stress is called shear stress of the shaft. That means it must be equal and opposite end couples, must be couple generated. Now, next point, polar moment of inertia. It is denoted by J. The moment of inertia of a plane area with respect to an axis perpendicular to the plane of the figure is called polar moment of inertia. As per perpendicular axis theorem, Izz equals to Ixx plus Iyy equals to J. As the section of the circular shaft is symmetrical, that is Ixx equals to Iyy. So, Ixx equals to pi upon 64 d to the power 4 plus Iyy as Iyy Ixx equal, so pi upon 64 into d to the power 4. So, polar moment of inertia J equals to pi by 32 into d to the power 4. Now, what is angle of twist? Angle of twist is nothing. When a shaft is subjected to torque, point A on the surface of the shaft comes to position, change to the position A dash. The angle AOA dash at the center of the shaft is called the angle of twist. That is, angle AOA dash equals to theta equals to angle of twist. This angle of twist is measured in radians. Now, torsional rigidity. Torsional rigidity is nothing, is the product of modulus of rigidity C and polar moment of inertia J is called torsional rigidity. On the other way, it is the ratio of torque per angle of twist is known as torsional rigidity of the shaft. On the same way, flexural rigidity. Flexural rigidity is nothing, it is the product of modulus of elasticity, that is E, and moment of inertia, that is I. So flexural rigidity equals to E into I. Now polar modulus. It is symbol as ZP. It is defined as the ratio of polar moment of inertia J to the radius of the shaft is called polar modulus. The polar modulus for a solid shaft, that is ZP, equals to pi upon 16 d cube, and polar modulus for hollow shaft ZP equals to pi upon 16 into outer diameter to the power 4 minus inner diameter to the power 4 y outer diameter. That is, the outer diameter equals to caps D and inner diameter equals to small d. Now, strength of the shaft. Maximum torque or horsepower of the shaft can be transmitted by a shaft referred to as the strength of the shaft. For solid circular shaft, maximum torque T is given y, T equals to pi upon 16 into tau into d cube for solid shafts. And for hollow circular shaft, T equals to pi upon 16 into tau into caps D to the power 4 minus small d to the power 4 by caps D, or T equals to pi upon 16 into tau into d cube into 1 minus k to the power 4, where k equals to, or it is the ratio of inner diameter to the outer diameter of the hollow circular shafts, and tau equals to shear stress of the shaft. As the shaft is used for power transmission, so power transmitted by a shaft is given by P equals to T into omega, where omega equals to 2 pi n y upon 60. That is, P equals to 2 pi n t upon 60, where T equals to torque transmitted in Newton meter, that is joule, and n equals to speed of the shaft in RPM, and omega equals to angular speed in radian per second. Now, strain energy due to torsion. The total strain energy stored in a solid circular shaft of diameter d and length L is given by U equals to tau square upon 4c into V, where V equals to volume of the shaft and tau equals to shear stress and C equals to modulus of rigidity, and V equals to volume of the shaft, where V equals to pi by 4 into d square into L, where L equals to length of the shaft and caps D equals to diameter of the solid shaft, and total strain energy stored in a hollow shaft of external diameter d and internal diameter small d is given by U. U is the strain energy equals to tau square by 4c into outer diameter square plus inner diameter square y outer diameter square into V, where V equals to volume of the shaft. Now, assumptions in the theory of torsion. The following assumptions are made while finding out shear stress in a circular shaft subjected to torsion. The material of the shaft is uniform throughout the length. The twist along the shaft is uniform. That means twisting angle along the shaft is uniform. So The next point, the shaft is of uniform circular section throughout the shaft. Next point, cross section of the shaft which are plane before twist and remain plane after twist. So before twist and after twist the cross section of the shaft is same, and all radius which are straight before twist remain straight after twist. That means all radius are same before and after twist. Next part of this torsion is coming soon, so waiting for the next part. Thank you.